All right. Good. Well, thanks for coming. This is good. Actually, I expected everybody to vanish this time. But, so, as I was telling Rachel, my wife last time, last time I had 85 slides. We breezed through them. And today everything we're going to do summarizes on one sheet of paper, and I'm not even entirely sure we're going to get through the whole. But what we're going to go through today is the actual basics of how the Python program or the Python language works. We're going to go absolutely step by step. Oh, and I have my teaching innovation here. All right, here we go. So hold this. So this is the spot. He's on the spot. And what happens is, I'm going to be asking two things. I'm going to be getting people to just guess what happens next. And when I say this, I want everybody to just come up with a guess in their head. Just think about it and come up with it. And then I'm going to ask the person who's on the spot, what's your guess? You can say it. And failure is good. Failure is good. If you, particularly the guesses, I'm not expecting that. And there'll also be questions. When I ask a question, I'm hoping it's something I've already taught, and I'm hoping I've already taught it well enough that you understand it. So when I ask a question, I'm going to, again, the person who's on the spot will answer that for the moment. On the spot will answer that, but I want you all to answer in your head, and if your answer is different from mine, I want you to stick your hand up, like instantly, and say, oh, I didn't get that. And I'm prepared to go over things 1,000 times if necessary, because if you lose it in the fundamentals, you will never catch up. Later stuff, oh, you don't understand this thing, you can look it up, it's not a big deal. If you don't get in the fundamentals, you will never be able to catch up. So we're going to go as, not painfully slowly, but we're going to go slowly and I'm going to make sure everybody gets each stage. And when the person, the point is, once you're in the spot, you just hand the ball to the next person. Right? Hand it like him. No, once you've asked your question. Oh. Once you've answered your question or your guess. So I want you to hand the ball to the next person, and they're going to be holding that ball for dear life. Or that's part of the reason my wife didn't show up. She couldn't have been better to do that, actually. Also, just a pain today. So, right, and so, and what I'm going to do is actually show you step by step, sitting in the Python interpreter, exactly how all the little parts put together, right from the basics. So let's start here. So first thing I'm going to do is actually start Python, which you should. And I'll give you instructions. We've got both Mac and PC people. I'll give you instructions how to do this later. Actually, you'll probably want to do most of this from within that PyCharm program that's on the installation instructions. It's got all sorts of things. It's really fancy. But it pops up all these windows and downloads and things. Very useful when you're sitting on your own. You can stop and figure them out. I decided when I was practicing this, no. Simple window, very, very little stuff here. So I'll give you instructions for PC and for Mac how to go about doing this yourself here. All right, so I'm going to, now, we are now sitting the Python interpreter. You can tell we're in the Python interpreter. It says Python on there, and then you see those three, right, I don't know what you call them, brevets or whatever they are. That indicates Python is waiting for you to type something. The way you communicate with the interpreter, which is the actual program, to understand Python, is to type something and press return. So I'm going to type something. Now, guess, what happens when I press return? What do you think it's going to do?
It's going to echo 23.
That's very good. Pass it on. Very good, exactly this. Pass it on. Look, here, I can do this again. I want some number here. I'm going to type some more numbers in, and we do this again. Very interesting. No, not really. Okay, so I'm just going to do some more of these things. What do you think? What do you think is going to happen when I press return?
It's going to say 1 plus 3.
Or
it might say 4.
4. Very good. Very good. Better than 1. 4. Very straightforward. It's a best desk calculator. It's a desk calculator. You can think of it this way. You can add lots of numbers. So far, I don't think it isn't really very exciting. And so what I'm going to spend the next 10 minutes is going through simple arithmetic with Python, which is, as computer languages go, very, very easy, but there's still a couple of details. And if you don't get this part, again, you're going to have some difficulty. So let's start with let's go on to some more numbers here. Let's start with the multiplication question here. So we go 1 times 2 plus 3. All right. Guess. It's still a guess. What do you think that's going to be? That's true. Hang on. Now, what about So what do you think? Again, a guess. What do you think this one's going to be?
I guess 7.
7. So here's a question about this one. Why isn't this 1 plus 2 times 3? That's 9. Why? Oh, sorry, hand it on. I'm sorry, this isn't a question actually, I'm sorry. This is a rhetorical question. I need a term for this. So what's going on here? Why, and I just know, perhaps a lot of you know this from high school algebra and things, but it's very, yes, exactly. There's something called the precedence, operator precedence. And what this means is the times symbol, star, glues things together more tightly than the plus does. So if you go back to this one, 1 plus 2 times 3, that times symbol there glues the 2 and 3 together more firmly than the plus does. Turns out there's the number one thing you should be thinking here is, wait, I have to memorize something. He told me not to memorize anything in the last class. Well, that's true, and I'm going to say 2 things. The first is, the times plus thing, you won't have to memorize that, you'll just get used to it. But the second thing is, if there's any doubt in your mind, do what I did here. Use parentheses. Use parentheses because you know it is correct. Use parentheses because it will, reduce your stress and difficulty. Like, for example, there are things I can never remember. I do something like 12 divided by 2 divided by 3. Now, is that 12, which is this? I don't remember. I can never remember this stuff, so what do I do? If I have to write this down, I always do it like this. So there's a concept of operator precedence, and we'll come back to this again later, and all it means is some operators glue together their arguments more tightly than others. I don't want to make such a big deal of this, except to say what I've said. All right. So now let's try something else here. Who's on the spot here? Okay. So what do you think? In fact, this is a question. What do you think this is going to come out as?
2.
Right. Okay. So that's good. Pass it on. So now here's a guess. This next one's a guess. What do you guess this one's going to come out as? Just throw a guess. You can't be wrong.
0.5.
0.5. You would think, right? You would think, but no, it's 0. And then why is it 0? Okay. So again, this is one of those things I'm going to explain. It's not very difficult, but I'm going to explain it slowly, because if you get it right now, you'll be good forever. Python has 2 different sorts of numbers in it. One sort of numbers are called integers. They're whole numbers like 1, 7, and this sort of thing. All operations involving those whole numbers, those integers, because mathematics term, end up as integers again. Anytime you do an operation with whole numbers, you're going to end up with an operation with whole numbers again. So you're like, well, that's no good. I want to have fractions. It turns out there's another set of numbers in Python, and they're called floating point numbers. Floating point numbers. Now, again, these are terribly geeky names, but you can call them decimal numbers if you like. So let's try this again. Oh, did you pass on the spot? Okay. All right. So, question. What do you think this one is?
No, it's going to be 0.5.
Well, it's going to be 0.5. Pass it on here too. You already got it, right? Okay. So what about this though? What do you think? I'll make the question. What do you think?
I think it's going to still be 0.5.
You are absolutely right. And in the same way, I'm not even going to answer this one. This one's also going to be 0.5. The reason is, floating point numbers are more general, they're more powerful than integers. So when Python gets what's called a mixed expression, when you have numbers of different types put together, it says, okay, I'm going to make these all floating point numbers for you. Which is what you want, otherwise life would be sad and miserable. So what's the advantage of this of your common pocket calculator? Anybody can do this stuff. Well, the reason, Python, of course, what we're intending to get to is strings. We're really interested more in dealing with text. But still, Python does shine really as a calculator. One of the things it has that your calculator doesn't have is it has what's called infinite precision. And whenever they say these things, you know they're a lie. There's only a finite amount of stuff in this computer. But you can still do pretty amazing things like 5 to the power of 5 to the power of 5. I have to worry about what this is. You get a number like, oh dear, didn't even fit on my screen. So you can literally, if you want to move, actually, you might see better.
Yeah, I think I will, but I noticed something. I don't know whether you're going to bring it up.
Yes. The L at the end?
The L at the end.
Absolutely. Good question. That was where I was going to go next. John, very excellent question. All questions are good, by the way. Seriously.
Especially my questions.
Especially John's questions. John's questions are particularly good. But all your questions will, actually no, everybody's question will be just as good. So what's going on here? You see that as John very perspicaciously noted, I thought I'd slip this by you, there's an L here at the end of this. What it means is this is a long integer. That's how it gets to its infinite precision. You don't really have to worry about this. It's one of the really nice things about this. But once you get into the numbers that are actually long like this, everything's a bit slower. If you're actually doing something, people actually use this for things like cryptography where it has to be fast. You'd really rather want to avoid those numbers because it has to go into a much more, it has to do more work. We'll skip that. So, yes sir?
How do integers behave, or do they round down to a certain number? Do they round up?
Oh, so in other words, if I do something like I want to actually so the question is, when you do a calculation between two integers, how does it figure out the integer value for the division? The answer is it does something called rounding down. And I think you saw this before when you did 1 divided by 2. Or if we do something like, let's do something like 5 divided by 2. Who's got the ball? You do. So 5 divided by 2, question, what do you think this is going to be?
It's going to be.
Oh,
maybe 2.
2. We can move this to, so it points up a bit. Is it too low for you in the back? No. Okay, good. It's going to give you 2. Absolutely right. So it always rounds down. Let's try 5 divided by minus 2. Anyone want to guess what this is?
Oh,
Just guess. Guess.
0? I don't know.
Well, let's give it a try. The answer is minus 3. Oh. Why does it
I
do?
thought wrong answers were okay.
They are okay. No. Truth to tell is, I wasn't secure about what.
I would have said minus 2.
Yeah, minus 2 is it. Minus 2 is a logical guess, and I was pretty sure it wasn't going to be minus 2. But I have to say, I wasn't 100% sure of this. Okay, why is it? It's rounding down. It is rounding down, which means towards the negative. So it rounds minus 2.5 to minus 3. Do you need to know this? No, but you need to know. You need to have a little asterisk in your head. Yes, sorry.
If you were done with that.
Yeah.
Sorry, so what if you wanted to get the computer just to echo 1 plus 3 without doing the math problem? Like, you typed in a thing and it...
Absolutely. We'll get to that in literally the next item on the on the agenda. So, I want to again emphasize that what I've revealed to you. I mean, like, let me just quickly. Let's do 5.0 divided by minus 2, just to make sure you don't think I'm cheating you. And that one's fine. So, the reason is that Python consistently rounds down, even though it makes your numbers go more negative. Do you need to memorize this? No, but you want an asterisk in your head that says, I'm dividing by a negative number. I remember in class there was something weird here. I'm going to do some experiments. So remember this always is, don't memorize things, but do be prepared to take the time to do the experiment and say, what is 5 divided by minus 2? Never assume anything, don't memorize things, but do experiments, look it up. All right, let's see where we're at on this. We have, oops, wrong one. Where we go? Comments. So now I'm going to put something because I'm going to actually occasionally type a little comment. You can all see the bottom line fine. Yeah. Okay. Great. So this is going to be a guess because there's no possible way to guess this one because I didn't. This is a comment. So the pound sign. That pound sign introduces a comment. All a comment is something you have put in your code for your information and interest only. What you're saying is, oh, this is a note to yourself. This is or more likely, this is a note to the next guy, right? And the next guy may well be you in 3 weeks. We're going to be talking about comments over and over, particularly when we get into the programming part. But remember, it's a sign of a good program to have good comments that you can understand. When you're actually building programs, one of the most terrible things is you yourself will not remember what you did a day or two before. Comments are the way you mark down not things that are obvious, but things that you will not remember or that somebody else who reads this will not know. All right, enough talk about comments. What do you think this is going to do? Guess.
It will just say this is
That is not correct. It's a pretty good guess. It's a pretty good guess, but no. That's just something slightly unexpected. It does. Well, firstly, it does nothing. It isn't going to do nothing because it's a comment. The whole essence of comments is the program looks at those and says, "It's a comment. I don't care. I don't care. It's a comment." But something unusual happens here. Oh, and you see these dots. Okay. So I told you no magic here. So actually, when I first rendered this, I became curious. I eventually asked Guido, who wrote the language, and he said, "Well, that's a surprise. I don't really know why it does that." In general, this is your first inexplicable thing. There will be more, but I just wanted to point this out. So basically, it did nothing whatsoever, though. You're going to see comments all throughout code when we get through. But I just wanted to introduce them at this early point because I'm going to be using them further. Now we're going to get into stuff we like. The next stage is, of course, strings. Your turn. So I'm going to type. Here we go. I'm going to type 1 plus 2. You notice they're in single quotes. Now, question. Even what do you think it's going to do?
It's going to return 1 plus.
Absolutely. So what if I do this? What do you guess? What do you think?
same thing.
Absolutely the same thing. Well, why? What's the difference between these quotes? Well, the answer is there is none. There is none. You get 2 sets of quotes you can use, and the reason is sometimes you want to say right. Sometimes you want to put a single quote in your string, right? Sometimes you want to put a double quote in your string. So the fact you have 2 different quotation marks lets you do this.
Is there any way to get to have it return it without the quotation mark?
Absolutely. We will get to that in a little bit. In fact, let me stop now. This is actually, it's very good. You're literally getting in fact, it's actually one thing ahead of more string operations, but I'll explain this right now. What it's actually doing in the calculator is it is printing out the value that it last saw, the display version of the value. The reason there are quotes around this is to tell you, oh, I just saw a string. The last thing that operation I did computed, and the result was this string of characters. I didn't do it. The quotes are there to show you that's what it is. Because otherwise, you'd have no way to tell the difference between this and this when you were doing computations. So in the desk calculator mode, this is what it does. You can certainly get around this, but it's really very useful because you want to. You don't want to. You want to know exactly what's going on. Later in programs, far away.
I'm sorry, no, just if you were to put a print statement before that, the quotes wouldn't show up.
Yes, absolutely. In fact, let me just do this since you're showing this. So you say something print like "Hello world," the classic thing, and there you can see this printed out. That's that print statement we're talking about. John.
I don't know whether this is important or not, but on the 1 plus 2 with the single quotes, you got single quotes.
Yes.
And then on the 1 plus 2 with the double quotes, you got single quotes.
This is a good question. It's part of the. You shouldn't allow. You don't want to allow magic in your life. Whenever you get a question like that, even small, if it bothers you, you should trail it down and find out about it. And also, there's one more thing you didn't point out is that we got. I had a pointer here. Oh, look, a drumstick. How appropriate. Someone's a heavy-hitting drummer. All right. So if you take a look, this has got single quotes, but this has got double quotes, and then this has got single quotes again. So what's going on here? Well, the answer is pretty straightforward. Not even that exciting, but it's good to ask these questions and get them out of the way. Is when Python is printing a string, it needs something to show that it's a string. its preference is a single quotes. Why? A little less real estate. You don't have to press the shift key. Tiny preference. However, in the case of this string, it can't print it out in single quotes because there's a single quote inside it. So it puts it as a double quote there to do this. So there's a question you may have. What if I have a string that has single and double quotes? What's going to happen? How would you make such a string? Right? This isn't a question, I'm sorry. It's a rhetorical question. Yes, I'm sorry. I need some other term for these. Anyway, a rhetorical question. Again, Python has a lot of nice ways to do it. One of the really nice things it has is what I call triple quotes, where you go 1, 2, 3 quotes, and then you can put whatever you like. I can put a single quote, I can put another quote, I can put 2 quotes, and then I put at the end, right? And you can see there, it's printed this out. Now what's going on here? In fact, let's just put triple quote, and I'm going to put hello, and I'm going to put a single quote and a double quote, and then more of this triple quotes. So what's this? Suddenly this character, did you see this? Look. What's going on there? I'm not going to get people to guess. It's too awful. This. Well, what's going on? Well, here's the trouble. Poor old Python. It wants to print out this string for you. It wants to print out this string for you, but it has both a single quote and a double quote. So how's it going to print it out? Well, what it does is the backslash says, just treat that character as a character.
It's focus.
I call those backslashes. I mean, it depends. Windows people, no, I call those backslashes. I think programmers don't call these backslashes. So you'll have to live with it. Sorry. So the backslash, you're going to actually see the backslash appear, and later on in a later lesson, we're going to see more backslashes. There are backslashes do all sorts of clever things like carriage returns, and tabs, and bizarre things like vertical spaces that only work on actually print terminals, which probably nobody in this room has ever used a terminal where you type in on a typewriter and it prints everything out and then it goes up. But there is actually a character that makes the roller on a printer go up one line. Not very well used. But for the moment, you can just remember backslash says, okay, that next character is just a character. So in this case, Python, when it's reading this, would be, without the backslash, it would read through and get to that closing single quote and say, oh, string's over. Okay, after the races, oh dear, what's the rest of the stuff? It would be an error. But the backslash says, just treat that character as a character. All right, so let's do something like this. Hello, I can't spell. All right, who's got the ball here? Question. What's this going to say? Cheating. Okay, you're right. You get he skips the next time. You're right. It's going to say hello world. And what happens if I do it this way? And hand it back to him. Oh. What do you think it's going to say? Oh, I pressed return. Same thing. Not very surprising. When you glue together two strings, you get what in geeky computer terms is called the concatenation of two strings. Terrible choice of words that's been around forever. Concatenation is just too long to type, right? That's why languages use words like con and cat, which are just even worse. They should have figured out something as well. But there's a bigger picture to be made here, and there's this concept that many languages try to obey. It's what's called the principle of least surprise. What that means is, when you do something, you want it to do the least surprising thing. You want it to do something that you expect. You have several choices here. I mean, it could do, once you're more familiar with Python, you can think of 3 or 4 possible things that this could do that would kind of make sense. But just gluing the strings together is the least surprising thing. So it's kind of, perhaps another way, again, computer scientists being a bit weird, is to go, you might call it the most obvious thing. But principle of least surprise is what this is called. So, we have strings, and there's all sorts of exciting things we can do with strings. We can say, let's do something like we say, hello, and now we're going to do something you haven't seen before. All right. So who's got the ball here? Oh, you didn't get down to one. You didn't get down to one yet. Okay. So this one's really a guess. I'm introducing several things we haven't seen before. What do you think is going to happen?
Hello, capital letters.
Oh, very good. Well, he's waiting here. So what's going on here? So what's going on here? So this is the first example we've seen of what is called a method call. This is a method. And you're going to be using two things for all your active needs. Every time you want to actually do an operation, you're going to be doing one of two things. Calling it a method or calling a function. And in fact, methods are just a special case of function. One of the nice things about Python is there are very few concepts. Other languages completely distinguish between a function and a method, terms I haven't fully described to you yet. In Python, they're basically the same thing. So what exactly is this? Well, again, I'm going to have to go a little bit into the background here. So we have a string here called hello. These strings in Python are actually what are called objects. That's actually quite a good name as opposed to the other bad names I've been giving you. All an object is some sort of data and some sort of behaviors on that data. So in other words, it's a chunk of data, numbers, text, whatever it is. It could be a big complicated thing, could be a dead simple thing. And then attached to that a bunch of behaviors, things that you can make it do. Those behaviors are called methods. So in this case, we have an object of type string here with value hello, and then we're calling this method upper. And that returns a copy of this string, all uppercase. So the question is now, okay, so the question is, oh God, now I have to memorize stuff, right? No, don't memorize anything. Don't memorize anything. Well, the question is, how did I know that there's an uppercase method? It's a method called upper on that string. How did I know this? Well, we're going to introduce a new, we're actually going to introduce a function here that will help you out. It's called dir. I'm not even going to try and get you to guess what's going to go on here. Actually, soon we're going to come up to interpreting errors and things like this. For the moment, just note this, and we're going to have a section on how to figure these out, how to understand what it says. But you notice, it's pretty straightforward. Since I'm taking sides, look, I'll take the opportunity here. Look, I forgot to, there it's reading along, it says, and EOL, okay, that's peaky, end of line, while scanning, not too unreasonable, string literal, that's that hello. And you can see what it's doing. It's going along, it's like, okay, here's an open single quote, I'm now giving you a string. As we go along here, and then, oh, what happened? Oh, I saw an end of line, but I was expecting a string literal. Again, Python excels in most of the time having good error messages. Find an error message you don't understand? Search it, Google it. Again, don't try and memorize any of this stuff. Always Google it, look at the documentation. There's huge amounts of documentation. So, all right, but let's go back and do that again. So, what happens here? Whoa! A screen full of stuff. These are all the methods on that string hello. And there's a lot. I'll give you a second to take a look at these. You don't have to memorize these. You don't have to understand these for the moment or this sort of thing, but it shows you, yeah.
These are all the methods you could use on it?
Yes. These are all the possible methods. So now you actually know what this string hello is. It's these collection of characters here, and all of these methods, all of these operations on this string length. So how can you possibly figure this all out? Well, it turns out that Python is very friendly towards you. Let's pick one. Forget about the ones, these things with the underscores. Those are called magic methods. And actually, they're not so magical. They're pretty straightforward. But let's, for the moment, just pretend you haven't seen those. And just pick one. Somebody pick one that you find interesting. Who's got their ball? No, you've had it twice. Pass on this. Okay, just pick one you like. Like one that's probably, like Z, I don't even know what Z-fill is, so pick one that's just really straightforward.
R partition.
R partition. Ah, you had to, I have no idea what that is. So I have no idea.
Pick the
No.
most perfect
So
one.
I have no idea what this is. That's the point. So I have no idea what. I have no idea about what 10 and 15% of those are, and this is the most common class I use. But so, I can actually just say help. Oh, isn't that nice? Hope I do hello
As it relates to bar.
dot. Which one was it? R
Partition.
partition.
Sell drinks, those are from this bar right here.
Voila.
They're gonna drink some out in the yard.
Okay, this is a little geeky here, but
So most of the time,
this is.
keep their eye on, but.
Okay, I'm not going to go through what exactly this does, it's kind of boring. But basically, the key point is not this particular thing, but the Python has a built-in help mechanism for each and every thing in the system. Every method, every class, every object, every single thing has help associated with it. Some of this help is extremely long-winded. I wanted to add another thing. I forgot yesterday that I wanted, last time I talked, I wanted to add to our list of things that we're going to do another thing, which is learn to squint. And what I mean squinting is, a lot of times when you're doing these things, you'll see something like, let's do something like help, let's just do this. Oh, so, yeah, that's true, it's not going to be help under. I'm trying to think of something that I help, okay, so here we go. Pages and pages and pages and pages of stuff there. Far more than you need. So why am I saying learn to squint? You're going to see this a lot in computer programming. You're going to go looking for the documentation of something, and you're going to see hundreds of pages of documentation. What you need to do is to learn to squint, not to get freaked out and say, oh my God, how can I deal with this? But just firstly look at the big picture and then scan through, not paying attention until you get to the tiny thing you want. It's it's one of the terrible things that we computer programmers not organize things enough that we don't have like huge things, huge spammy things that are confusing. So one of the key things you need to do is learn to squint your eyes, get the big picture, and then scan through till you get to the part you want. You had a question?
Yeah, so when you call help, you could call help if you were calling a function or
Yes.
on something, you can call that within the help function and it will still.
Oh, no,
I
that's a
saw you
question.
did up there, help, and then you called hello into architect.
Right, but you notice that I actually, let me revisit that question a little bit later, okay? That's a good question, but I don't want to get, it'll be much more obvious in about 30 minutes. But basically, you are right, you can call it on any function or method you like. And so now we've introduced we've introduced a method on string. Let's just jump back and say, oh, I actually glossed over a bunch of things, that there's a huge number of extremely useful functions. And you're like, what's the difference between a function and a method? Well, it's very straightforward. A function is something that stands alone, that is not attached to any specific object. And do stop me, we're getting a little obscure here. But let me give you some examples. Here's a very useful function, max. Okay. Who's got the ball here? Guess. Guess. What's this going to do? It's going to return 23. It returns a maximum value of everything it has. We also have min. That's in fact, I can just use the last name. Min. Hand the ball on. And actually, hand on to. Oh, who gets it? Who starts? John, did you get it yet this round?
Nope.
Oh, okay. Go for it. Right. You show me. Min.
0.
Very good. So there's a large number of these functions. Max. Big pardon?
Why are you entering only 3 numbers at a time? Is it just...
Oh, I just picked it here. I could do,
Okay, so I can still have more.
yeah, as many as you like. Yep.
Sorry, this might be a redundant distinction, but I know you said that methods are attached to objects.
Yeah.
Is technically the data and the parameters objects of their own? Or,
Everything in Python is
but
wrong.
it's not attached to it, right? The same way you would as if you would have used a period.
Oh, no, it is not attached. The min, in fact, the min function actually works on a whole bunch of different types. For example, you can do something like this. You can do min A, B, C, D, E, F. Who's got the ball? Guess what's this going to do?
ABC.
And if we figure out how to do that.
Absolutely right. And again, it's one of those nice things about Python is nearly always you can guess what it's going to do. It compares the numbers in dictionary, not the numbers, it compares the strings in dictionary order, standard order you'd use if you're looking up things in Webster's, and gives you the min. There's a very large number of functions. I'm actually thinking I was going to go through a bunch of them. I'm like, what are we doing for time? Yes, so I'm not going to do that. I'm not going to do that now. Suffice it to say, there's a large number of functions. There's probably a function to do what you want out there, and I will present you afterwards. I'm going to give you, I believe, pointers to like some pretty good lists and explanations of these things. All right, so let's see what we're at. No, I'm actually going to go back. I'm going to skip booleans, and so I'm going to get quickly to. I'm going to quickly to. Is it been? Oh well, we knew they were going to be. Sorry, they're having a bar meeting there. I should add. They'll be on in a few minutes. So I'll just talk. I shut up?
Yeah.
I wasn't trying to shut him up. It's just fine. We can all do this. Okay, so actually I'm going to even skip the section on errors and things, how to interpret them. Now I'm going to start getting to something I hope is interesting here, which is lists. Now, one of the reasons that you're here, I hope, is because you want to manipulate text, or maybe there's other people here who just, I don't care about the text, I want to do graphics, I want to do music, whatever it is. So one of the key things that makes Python such an easy thing to use is lists. You can just create a list of things. And if I do this, it's even worth it guessing. I'll put this in. We have a list. Who cares? And now I'm doing this again. I'm going to split that first section up. Table this for a second. We're going to now go to variables in the state. It'll be much easier than me retyping all these lists. Okay. So this is all very well. But the trouble is, you're going to end up doing, like, what good is this? You have to retype everything every time. You know, how can you make progress with this? Well, we're now going to get to variables. And variables are exactly what you may believe. If I do something A equals 23, you've got the ball. What do you think is going to happen when I press return? No idea. Very good answer. Nothing happens. Apparently nothing happens. Well, what happens? Well, remember before in my previous episode, we talked about the state. What the state is a set of assignments from variables, which are just names, to values. In this case, in this case, we have a new variable called A, so what do you think is going to happen when I press return? Guess.
20.
Yeah, very good. Right? I can keep doing this till I'm blue in the face and always remember this. So I can say things like now A equals A plus 2.
Is there a way to undefine something?
There certainly is. You're about 45 seconds ahead of me. Yes, absolutely. There is a way. It says right here. Sorry for that. Let me actually get back to where I was now. Because del command. So, and let me see, what the hell, since you bring it up, it takes 2 seconds, is you want to forget about A? Delete A, del A. Del is actually more general purpose, you get to see it in a whole bunch of things, but it just says, remove that reference, don't want it anymore. Now when I type A, who's got the ball? Guess what it's going to do?
Nothing.
No, it gives you an error. And the reason is, 1 second here, and the reason is again, previously it was a name, now it has to tell you, no, I don't know about that name. Because you could say something like A is equal to the empty string. And then if I said A, we'll continue. It's still very, so it's actually, it needs to tell you, oh, you asked for this name doesn't exist. And again, this is pretty straightforward. Again, I hope you're squinting and squint past that first line for the moment there, that's a little cryptic. Blah, 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 blah. But the second thing is very, very clear. It says name error. There we go. Name error, exactly what it is. And then the name, A, quote A, is not defined. And that's absolutely true. I undefined it there. Yeah, you had a question.
Does delete work to have the same behavior in compiled code as if you like to define X as 4 and then you have the delete statement on the X, and then you
Well,
Then
wait,
it ran it through,
well, you mean, are you talking about like compiled Python thing?
Yeah, no, well, I'm talking about if you like wrote like a code sheet of Python that you were gonna
Oh.
save as a PY.
Oh yes, absolutely. It works. Yes, it does. It works exactly the same.
Okay.
I mean, yes, it works exactly the same. There's no caveats there, except for the fact that there's more complexity than names than I'm getting into right now, but it works exactly the way you expect it to. So now we have a sign. We can so names can be whatever you like. There's no limit to the names, the length of names. You can put in underscores, these sort of things. You can put in underscores. That's kind of shift minus. You can put in numbers. The one thing you can't do, of course, is have the first letter of your name be a number. Because then you think it's a number. So, and it's a very simple concept. We're going to be using it over and over and over again. And so here's a question, not a question. Here is a rhetorical question: so I've just created a bunch of names. How do I find what they are? Okay, this is a little obscure, but there is a function, a global function called globals. And look at this, it prints out all of this stuff in here. Again, gotta learn to squint here. So you look at this and you're like, oh, okay, I don't understand the things with the underscores, but Tom said I don't have to deal with these, or they're not relevant to the question at hand. This is the key. Learning to squint your way through things like this is key to advancing here. So let's take a look at this. A, remember I defined it there? There it is in this, there is A defined. It says A, that's a value, an empty value. Here's something you can squint at. What the heck is that? Don't worry about it. Oh, here's my long thing, I gave it the value 23. Oh, underscore package, what is that? Tom said not to worry about it. So again, you squint your eyes at this. Here we go, here's that long one, here's the value. So, by the end, we will explain. By the end, you will actually understand what those underscores and things are. For the moment, squint your way past it.
Is that a dict?
That is a dict. We're getting to those in about 7 minutes. Getting ahead of the game here. So, let's get that. Good question. Yeah, we'll get to that in about 2 seconds. No, about 10 minutes. So, okay, there's just a couple more things we're doing on these variables. There's really only 2 ways to change variables. You can say something like A equals 42. Oh, and you notice I just overwrote the variable that was there before. Remember it was quote, now it's 43. I can now say A equals 17, whatever I like. It overwrites it. No problem. But what happens if I want to just increase that by 1. You find you want to do this all the time in a computer program, you want to add 1 to something. So you can say A equals A plus 1, right? And then when I print A, who's got the ball? What do you think it's going to do? 18. Yep, right? So but what if I do A plus equals 1? What do you think it's going to be? What?
Oh, wait, plus equals?
Yeah.
Plus, 19.
19, very good. Very good. And you can say also A times equals 2. And it's going to do nothing. What will A be? No, times
I'm not very good at
yeah, a lot of math. A lot of math. Yeah. Again, you don't need to know math to do this. Don't rely on your math skills for any of this stuff. So what this says, let's go back then. So this is A 2, right? Yeah. So A was 19. So this statement is pretty straightforward. This says A equals A plus 1. A equals A times 2. You can even, and that's going to be 38. You can also say A equals A divided equals 2. It says A is divided by 2. I see some furrowed brows here. It's the first time I've seen some computers. Well, here, good question. If I do A plus 23, I get this number, but A isn't changed. So A plus 23 is an expression. I can even say something like B equals A plus 23, and B will be 42. But if I say A plus equals 23, it changes A. Well, the point is, this isn't even, this doesn't even have a value. I can't even say B equals A plus equal 23, I'm going to get an error. Syntax error. Why? Because that's not that's an operator. This doesn't have a value. A plus equals an actual operation saying add 23 to. So that's kind of the way to read this operation here. This plus equals symbol says add 23 to this. This times equals symbol says multiply this by 2. Yes?
I mean, I think it feels sort of weird to try to actually describe, I forget what they call these operators.
These are called assignment operators.
I mean, it feels sort of funny to try and actually have it make semantic sense, because in essence, to me, it's sort of a convention of do the most obvious thing, but because we're going to do this so often, let's make something a little bit obscure.
That's
But
basically
it'll
it.
pay you back because
It'll pay you back, and remember is, if you don't understand it, you don't have to use it. There's always another way to do it. The reason I'm pointing it out, you'll see this in other people's code. I should add that, particularly, I've gotten into terrible trouble. I spent hours the other day dealing with something where instead of saying A plus equals 23, right, I said A equals plus 23. Oops! So that gives you 23, of course, right? Because this is the same thing as saying A equals plus 23, number 23. Oops! So that took me hours. I stated this over and over again. So there's definite traps in there. You had a question?
Two quick things. One, the basic name for the plus equals one is called the incrementer. It's like the same thing that you would use in like a set.
Yes, it's exactly. You can call it incrementing if you like.
And I just lost my second question.
Well, don't worry. We'll just yell it out when you get to it. Okay. So now we're going to get right. Now we're going to get back to the
Oh wait,
list.
these were called assignment operators?
These are all called assignment operators. The big assignment operator is equal. You don't really need to know the other ones, frankly. If you have to write A equals A plus 4, nobody is going to fault you for this. In any of these cases, it's like what I said before about the operator precedences. If you can't remember what thing glues the best, put the parentheses in. Nobody will complain. It'll be easier to read. In the next lesson, there's actually going to be a whole minor lesson on what's called Pythonic. Pythonic. Love that word. And it means in keeping with the spirit of Python. In fact, if you can, look, you can print it out here. If you do import this is a joke. This is the Zen of Python. It's a little poem. Beautiful. It's better than ugly. So. Yeah, this is classic. Classic thing is this is the Zen of Python. And actually, if you read these, they're all very straightforward. Readability counts. Special cases are not special enough to break the rules. Now it's better than never. Oh, and there's some jokes in there. That way may not be obvious at first unless you're Dutch. Guido van Rossum is in fact Dutch, so that's where this comes from. Anyway, back to lists. Okay, so before we had a list, now I have variables. So instead of having to type lists again, I can assign them to variables. I should stop. Are there any overall questions? What we're missing? You're understanding this is great. I'm not talking. So we have A is 1, 2, 3. Fantastic. So now we have a list. Well, what good is this? Well, it turns out that there are all sorts of useful things you can do in it. There's a global function called length. And again, length works on a whole bunch of things, not just lists. You can see that's length of that is 3. Let's suppose I'm going to do something just out of curiosity. Who's got the ball here? Guess, what do you think this is going to return?
just 1, 2, 3 column.
No, but well, take a look at the previous thing. Well, length computes the length of the thing it has.
Oh, I see. I get 5.
5, right. So, and again, like, the same principle of least surprise. The same idea, the principle of least surprise is you hope that the length operator works on everything, and in fact it works on everything just the way you would hope it would. Very nice. But what good is arrays if you can do length? Let's pick another one. B is equal to, 4.5. Great. So who's got the ball here? Great. So what do you think this is going to do?
P equals
It's a guess.
5 and A plus B.
It's okay to say I don't know.
I have really no idea.
Okay, well, absolutely, this is not, that's why I said it was a guess and not a question. Well, let's try and figure out what might be most obvious. You have one list, and then you add to it another list.
So it's gonna make a bigger list, so it's gonna go list from 1 to 5.
Right. Fantastic. There we go, exactly right. It's possible.
So it's,
So, right.
you're not adding matrices.
No, obviously, yes. So, yeah, so I can see why. Yes, you're not, in fact, doing matrix addition. Yes, it's one of those things. Is this the least surprising? It turns out that this operation, which is called, again, concatenation, hate that name, this operation is incredibly common. So, yes, I could see there might be some possibility to claim the matrix addition, which the rest of you don't have to worry about. Okay, so you have things, but what use is how do you get things out of array, out of lists? Well, let's try the following. So we have, so let's go back to A. We have A here. So now we're going to introduce a new notation here. I'm going to say A bracket 1. So who's got the ball here? Oh, John. This is slightly a quick trick question. What do you think? What do you think the value is going to be here? Oh, let me put out A for you just so you remind my mind. So A. Oh, I did.
You did.
Okay. So what do you think A bracket 1 bracket means? Yeah.
2.
You're right. It's 2. It's going to be 2. But so the question is, well, wait a second. Why isn't that 1? Why isn't that the first element?
Computers count.
Yeah, well, it turns out it is kind of how computers count, but it's really just a long-term convention. Computer programmers start counting at 0, not 1. I could give you a lot of justifications for this. It's kind of how machine language works, but basically that's just what we decided years before I was born. So let's go to the next question. What do you think A0 is going to be? 1. And of course A2 is going to be 3. And what's A3 going to be? Possible one? Oh, is it? It's her. It's you.
I guess 4. I actually don't understand what's going on.
Ah, okay, good. Very, very good. I'm glad. I knew at some point. I should have like some present I give to people who admit this. Okay, so this is very important, and we really need. So for the rest of you, the people who do understand this, take a moment here and just call out secondaries. But it's very important to get this right. You won't get anything else, and it's not so obvious. So A is a list of 3 elements. We needed a way to extract any one of those elements out. The square bracket notation, it's called indexing. Sometimes they call it subscripting. Terrible names, I agree. But indexing is perhaps as good as any other. Like looking things up in an index card. What you're saying is extract the element at this position and give it to me.
Okay.
So A0 is the element at the 0th position. Remember we started counting to 0. A1. So here's let's go back to A. What happens if I say A0 equals 23? Check that, but it equals in there. Did you answer a question?
I just said I didn't know.
Possible. You didn't. I don't know is an answer. Calvin told me that one. Okay. So when I do this, what do you think? Well, firstly, what do you think I'm going to
Is it changing the first element to 23?
That is absolutely correct. So, but it's going to print out nothing at all because it's an operation, doesn't have a value. And then when I print out A, the first value is going to be 23. So, and you can even do, it doesn't have to be a fixed value. I can say something like I equals 2, and I can say A indexed I with I is equal to 19. So you're following along? This isn't that tricky, but right. It is tricky. It's just not hugely tricky. Okay. So what is A? Who's got the ball? What do you think A is?
23, 2, 19.
Perfect. 23 to 19. So I'm going to stop here. Was this a surprise to anybody? You sure? Absolutely. All right. Because this is a key idea, and these things are really, really useful. And you know, like everything else, all this principle of least surprise is going to keep coming up here. Like you say, a plus equals 1 comma 2, right? And what we're going to get? We're going to get a is going to be had those last two elements glued to the end of it. Straightforward. It turns out that now arrays, lists, rather, forget I said the word array. Lists have a huge number of operations. And again, we have our favorite dir directory function that gives you a list of them as a huge number of them. Actually, it turns out that there aren't though. Most of these are magic methods, which we will get explained, but not right now. And we're going to say a tiny number of these: append, count, extend, index, insert, pop. There's only a small number of these. Let's try some of these. Let's do a.sort. So any ideas of what we're going to get? No, somebody's got the ball. So let's take a look at A. Okay, and now we're going to call this method, in other words, we're going to call an operation on this list, and called sort. And what do you think we're going to get?
Yeah, just sort the numbers, 1, 2, 19, 23.
Right, fantastic. A.sort, but didn't print it out. Wait a second. Well, okay. So no, it did. In fact, the result of this is that A was sorted. What's your question?
If you did sort and then A and B in brackets, would it have printed it out immediately?
Let's try it. Let's try it. Good question. Very good question. In fact, you're jumping a tiny bit ahead. Let's do. No. You're jumping like ahead, like literally to my next step. Supposing I did this. In fact, we'll give you a turn too quick. What do you think it's going to do?
I think it's gonna print out the sorted list.
But so the reason why is that would be. Well, let me tell you the correct way first, and then you'll see it. The actual thing is sorted A.
Oh, and that's
Sorted.
technically the function of
Yeah.
the
So
same.
the idea is they wanted to make sure that you didn't make a mistake between the method and the function. That's pretty important because you see, the method actually changes the list itself. If some other part of your program has access to that list, then you have just changed that list for them.
Do methods actually change the data that's in storage, whereas functions
Method.
just return it, or?
Some methods change the thing. There's no general rule though.
Okay.
There's no general rule. For a lot of these built-ins, the functional version does not change what's being applied to, and the list version does. The method version does. Here's another example. Let's do a.reverse.
Well, it doesn't matter to us. Yeah.
Right? And now we see A is reversed. Straightforward again. I can do, if I do it again, I don't think anybody will be surprised to see it's back to where it came from. Okay, but if I say reversed A, okay, so here we go. You're like, whoa, what happened there?
That's X, isn't it?
Yeah, you don't have to worry about that. It's, debating whether I should explain this to you. I'll give you a tiny explanation of what's going on here. Here's the thing. Python sometimes does stuff like this, and it has your best interests at heart. You don't, a lot of the time, particularly when you're dealing with very large lists, and I should add, you can temporarily, if you're getting a bit overwhelmed, you don't really have to listen to this next part. I'll be getting back to this in like 2 lessons from now, the details of this. But I figured there should be no mysteries, but this isn't so key and everything else is. A lot of times, if you have a very long list, you don't want to actually have the reverse list. You just want to go through the elements in reverse order. Now, if you actually create a whole list with the elements in reverse order, you have to use a huge amount of memory. Well, no, I mean, it's a huge list. What this is an iterator. It's something that's like a list, but allows you to go through the elements in order without creating the list. And you're like, so we'll see more examples of this later. I'm going to have to teach you some more stuff before we can actually use this. But for the moment, if you wanted to get that list, luckily, you can just say, okay, I want this to be a list. And there we get the thing reversed. Most of the time I say if you didn't understand something, you should ask me. But I'll bet you half of you didn't fully understand that. We'll get back to it, and when you see it the second time, you'll be like, okay, it makes sense. So, and this will happen sometimes. This is what's called Python being lazy, right? Sometimes it doesn't want to work out the whole calculation because sometimes you want to do something like just go through the last 3 elements or something like this. It doesn't want to. It doesn't want to work out stuff that it doesn't have to do immediately in some cases. So whenever you see something with the word iterator in it, it's very likely Python is being lazy. It might be a little confusing for you now, but when you're dealing with big things, it's really, really nice to know that Python will automatically just make a huge copy of the thing and then do some tiny operation. All right, I'm just going to move on whether or not there are any questions on this. So there's some other very, and let's go look at our list there. Later on, I'm going to do more work with lists, but I think this is a good start. There's a bunch of other useful things there. Let me just show you one actually. We have A here, and we do A dot append ABC. Oh no, wait a second. So what's going to happen here? I'm putting numbers on the end of this. Putting a string on the end of this list. I think you'll guess the append. Well, the answer is just get the list. And so that's another thing that I should have been pointing out before is lists can be listed absolutely anything you like. They can even contain B equals A. They can even contain other lists. Look, here's a list of 2 lists. You can have lists of strings, you can have lists of numbers, you can have lists of any object you like. It's just a completely general purpose way of gluing together things in a sequence. Is that clear? Okay. Now I'm going to try something a tiny bit. No, I'm not going to do that. I'm going to keep with my program here. All right, yes, I should have done it. Now we get to something called dictionaries, as you pointed out before, or dicts. These are an incredibly powerful feature of the language, and I can't emphasize how much fun they are to do as well. All the time I'm dealing with people's code, they have like 50 lines of this. I'm like, hey, you can do this with a dict. It'd be like two lines. All the time, it's one of my great joys is to look at people's code. Use a dictionary. Oh, well, what is a dictionary? A dictionary is exactly what you would think it is. It's a way to look up values in a dictionary. So you're staring at something. Is there something on there that's puzzling? Okay, good. I just want to make sure. I've spent a lot of time in classes being hopelessly confused, by the way. So I don't want to inflict that on anyone. All right, so let's start with a dictionary. Let's start with a simple dictionary. We'll call it D. So we're going to think of A. And we're going to say, bear with me here, A, 1, calculator, B, 2. All right, so this is a simple dictionary. We saw one of these before. Oh, D. So we saw one of these dictionaries before. It sort of showed up. But what is this? Well, this is a mapping. This is a dictionary, and it says, okay, I have a dictionary, and it has only two elements in it. Attached to the name A is the value 1. Attached to the name B is the value 2. Okay, how do I get things out of here? Who's got the ball here? Prepare for this next question. What do you think is going to happen if I do D, quote, B? It returns 2. You are right. So you notice it's using the same square bracket notation to look things up in a dictionary. Again, it's that principle of least surprise. I'm going to keep repeating it here. I'm going to keep repeating this here is the square bracket operator is look something up. And it applies to all sorts of different operators. So if you see this, you know that you're looking something up. So this is important. Is this looking something up fairly clear? Did you have
Anything in the dictionary?
That's very true. That's my very next thing I'm about to say. This is good, by the way. Is every time you say something and it's something I'm about to say, it makes me feel good because I'm like, okay, good. I'm making it clear. So I can do the reverse thing. I can say 1, A, and 2, call this D2. So this is a dictionary mapping. So this dictionary here is mapping strings to numbers, kind of like a phone book where you have one-digit phone numbers. So this is the reverse. This is just mapping numbers to strings. And I can go say D2, 1. I get A. And if I say D2, A, who's got the ball? Did you already answer one? No.
No.
Yeah. What do you think's going to happen?
1.
Error! So sorry, that was a trick question.
So it doesn't work backwards?
No, it only works one way. It would be horrible if you think about it. It would be pretty bad because what if a key was both? There's no reason the key can't be both a value and a key. I should add. I'm sorry. Nomenclature I didn't mention. This one is a key, or here this A is a key. This is a value. So what a dictionary does is maps keys to values. So there's also some names for these in the literature that in Python they used to call them associative tables when I was young. Great name. I'm joking, by the way. It's a terrible name. But now, or associative store. That was even worse. Store. What the? Anyway, because it stores values. But a dictionary is pretty good. I actually like this. But remember that unlike a real dictionary, a key can be any type, or I should say almost any type you like. Let's try the following.
Wait. You had your hand raised.
Do you have your hand raised? Oh, sorry.
Yeah,
Thank you.
let me ask a dumb question. You didn't.
There are no dumb questions, just dumb teachers.
Let this dumb person ask a question. So, so you didn't change A by like making that dictionary. Like if you printed A, you're still gonna get the list.
Absolutely. Yeah, in fact, let's take a look at we've probably generated huge number of things. Look, you can see that the A here is the same as it was. B, and that's that list of lists. Oh, I created an I there. There's D, D2. So.
I get maybe I'm jumping in, but like what purpose would this serve? Like if could you make the key like something like list of ages, so if you wanted to
Absolutely. That's exactly what it would be used for. You could absolutely do something like ages equals, Tom, 90,
Do it, Tom.
90,
Right now it's cool, but I think if we have
etc. And then I could just look up and say age of Tom, and it's going to say, oops,
You said
ages.
if they're in this jar.
Ages Tom. Right.
Do you use digs to consolidate code though? Like let's say if you were repeating like a method a bunch of times.
You can. We'll get to this later.
That's more advanced, I guess. But
Yeah, it's more advanced. Particularly, what it does, what you do see in a lot of code is people say, if name equals Tom, then return 90. If name equals Nat, then return 12. If name, and you're like, no, use a dictionary. So that's the simplest way. But actually, in fact, one of the secrets of Python is behind every object is a dictionary. It's like behind every man, a great man is a even greater woman or something like that. But behind every object is a dictionary. Don't just treat that as a piece of mystical learning from now and then.
But that means like when you say like x equals 4, x is technically the key. And that's an object x.
Oh, yes, so in fact that's true. So in fact, look, the globals, this is a good point, and this is an interesting point as well. So even though it's not on the curriculum, I'm going to still go through it even as a slight thing. What happens when you say A equals 5? Well, it turns out that there's a dictionary whose name is globals, yes? And when you say A equals 5, it really actually just creates a new, here I did I equals 2. It actually created a new entry in this special dictionary called globals and assigned that to, gave that a value 2.
And that's the dict that you bring up.
So that's the dict that I'm actually, when I'm sitting there in this empty Python shell, there's really a hidden dictionary called globals behind there that keeps track of all the names in there. And it turns out also that all these other things, like I won't get, but like when it looks up a method, remember we have all these methods on things, methods on strings? Oh well, those are all stored as dictionaries too. Like everything in Python is stored as a dictionary. And dictionaries are very fast as well. They're really, really highly optimized. And you can put everything in a dictionary, or pretty well anything for a key. Now, I debated whether I was going to go through this next point, but I think I'm going to tell you about this because it's important. Because even I get a lot of questions about this thing. What can I use for key in a dictionary? Right? So you can see right away. Let's go back to these two examples. Clearly, I can use strings, and I can use numbers in a dictionary. Right? Well, can I use lists in a dictionary? Let's try this. Let's say A maps a list 1, 2. So the number 1. Who's got the ball? Total guess here. It's going to work or not?
I think it's gonna work.
You want to know. In fact, it's the worst is I actually only really figured this out properly a little while ago, and then I actually had my brother-in-law, who's actually pretty advanced, send me an email like 4 days ago asking, what's this unhashable type? What's going on here? Okay. I'm not going to entirely explain what hashable is. I love that word though, it's great, but I'm not going to explain it. Here's the trouble is, you can't use a list to store something in a dictionary, because lists can change. That's the thing. Like supposing I say, well we have A equals, let's go back to doing this, and then I was able to do a dictionary that goes, maps A to 17. So, which is not allowed.
Does that mean dicts don't iterate?
We'll get to all this. So what would happen if I went and changed A? If I could make this dictionary, what would happen if I changed A? Would it keep the original entry, or would it move the entry to a new list, or what would happen? Nobody. So basically, it's not clear. It would actually, it would be bad to do. It's like so. Generally, you're only allowed to use what are called immutable types. This is a new word. An immutable type is a value that can't change, like a string or an integer. You're like, but wait a second. No, I say you do all these operations with strings. But it turns out there is no way to change a string. If I say A equals 1, 2, 3, 4, 5, right? There's no operations I can do on that object A that will change the value of it. It's what's called immutable. It never changes. Right? I can say something like A equals A plus 3, 1, 2, 3, but that isn't actually changing this string 1, 2, 3, 4, 5. It's creating a new string. I don't want to belabor this point too much, but the point is that this is a way that Python prevents you from shooting yourself in the foot. If you could actually change if the values that you are using to the keys in your dictionary could change, life would be grim and horrible. You would keep having problems over and over again. C++ does not have another language I program in, does not have this restriction. Constantly it causes problems. Even people who've been doing language for years, I've been programming this since, I was about to say longer than some of you being alive, probably not true, but I've been programming C++ for 20 years, I still shoot myself in the foot with this. You develop disciplines in your code just to avoid shooting yourself in the foot this way. Python is good. The safety guard goes off when you're pointing it, basically. So I'm not going to belabor this point too much. If you didn't get the last little bit, don't worry about it. Just remember that a dictionary is a way to look things up, and you can put, particularly the values in a dictionary, I should add, can mean anything, absolutely anything. I can say D maps, is a dictionary mapping 1 to and B to 1, 3, and there'll be no trouble with this. Let's take a quick break here, and then we'll go back and we'll start. Yes, as I figured, it was. I thought I would run out of time, and we're not even halfway through. Take a 5-minute break. We're going to do another 20 minutes after that, and then we'll be done.
If anybody wants me to make them an espresso, you can do it.
Yeah, good idea.
Since that separates lists from lists, technically it's lists are reiterated, meaning they're like put into a list and you can change what's in them.
Well, no, but you can see what's in the
But you can't change the individual.
you can't change the themselves have to be immutable.
And I guess that's the same with a list.
Oh,
Zero is well, you can change the value of zero, right?
you can change values, you can change the entry into your, like, here, I'll show you, like, using, like, here we can say D, I'm gonna do this, you say D1 equals 17, 15, and now I did a list, so you can change what's assigned to each value. This is good. I'm glad you mentioned this, because I'm gonna reiterate this before we go.
Okay.
Yeah, I mean, there's a whole, open time. Right. There's another, there turns out to be another basic thing that we're gonna get to called, tuples.
Yeah, I remember.
Just like lists.
I think there are many ways to explain this. It's one of the problems.
Closer to, oh, okay. So they're like lists that are dictionary friendly.
You got it. Thank you. Oh, what's your name, by the
I
way?
mean,
Oh, I'm Ray.
Oh, Ray, you're right.
That's okay, Tom, right?
Yeah.
there are a lot of ways to explain X, and there are various ways to look at it. There's programmer lens, language, lens. There are different ways to look at it. So like, and I just think that, so say that like he was breaking it down programming semantics point of view, like the equals in the case this and this. My point of view, it's just like after just looking through a lot of code, there are a million it's like this thing equals what it is. So, for the sake of making this way easier, we're just going to use something. You're going to be able to discern what it has this weird code stuff. And the way you're going to figure out what it does is because it's I mean, so it's really like just something to mention. Other documentation.
Some of the other classes are like, that's just me, the next one is
Yeah, well, you know, better.
Yeah, I have a friend who's a coder, long time, 30 years, and he got into coding at a fraction age, and as he's grown, hates he feels like his situation is a better representation. He feels like subset of our understand what he was getting himself into. Just like, do anything. Not understand what's going on.
So,
Well, it should be, when I tell you, that's why.
Basically, if we staff it, we would have been able to pay some $15, and that's the only.
No, I saw that. A lot of people.
Basically, people pay about
And that probably, I thought about that.